In today's lesson, we're going to review some of the basics of functions. And the first thing we're going to start out with is our definitions of relations and functions. So a relation is any set of ordered pairs like we have below. We have these sets of ordered pairs up above, which we generally have that consists of x and y values. Okay. And we call the first set of an ordered pair, first component of an ordered pair, the domain. So our x values, right? And we call that second component our range, and that's all our possible y values. All right. And so if we remember the big difference between a relation and a function, our function is almost the exact same idea, except for the fact that each element in the domain corresponds to exactly one element in the range. And that exactly one thing is the big piece here. Okay. And so generally, if you remember from our past years of math and talking about functions, what we look for is, if we go down to this example below, we look for repeating x values. And does any x value have multiple y values, right? Because it can only correspond with exactly one element in the range. And you'll notice here our x values are 1, 2, 3, and 4. And so we have a function because we have no repeating x values, or no x values repeated to go to a separate y value. All right, so we're going to get some practice with talking about figuring out whether or not a relation is a function first, and then if we're going to talk about our domain and our range. So first of all, in example 1 here, and we're going to skip around a little bit. In example 1 here, okay, we have x value of 1 corresponds with 4, a y value of 4. We also have 1 goes to 5 and 1 goes to 6 in all our ordered pairs. So you might notice that this means that values in our domain, so 1 being in our domain, corresponds with 3 other values. So this makes this just a relation, since 1 corresponds with 4, 5, and 6 in the range. So we're also going to write our domain and range out. So when it's with ordered pairs, it's a little bit simpler. So we're going to use our domain. I'm going to use a set of braces. The only x value we have is 1, and we don't need to repeat. Since 1 repeats 3 times, we can just leave it as 1 is in our domain. And our range, once again, we're going to use a set of braces of all our y values. So this is 4, 5, and 6 from our ordered pairs. I'm going to skip down to 3. Okay, what we have is x squared plus y is equal to 25. What I'm going to do is I'm going to subtract x squared from both sides and reorder this as y is equal to negative x squared plus 25. Okay, I want to reorder this just because this might be a little bit easier for you to determine the domain and range from, because this makes it a little bit more visual for graphing purposes if you were to think about this graph. So if you were to think about this graph, what we have is a quadratic, which means that we have a parabola here with a negative a value. So if you remember, okay, that means that we are going to have a parabola opening down. Okay, so we can think about this for a second. And in terms of whether it's a function or a relation, if you think about a parabola passing the vertical line test, which we'll cover again, this will be a function. Okay, and then we'll talk about domain and range. So our domain is going to be determined by the restrictions that we've talked about in math before, that you've learned about in math before. Things like not taking the square root of a negative number or dividing by 0, right? We have no restrictions in terms of what can go in as an x value, or what we can plug in as an x value. We can plug in every type of number as an x value into this function here. So our domain is all real numbers, and you can write this a few ways, but I'm going to use interval notation and say that our domain is from negative infinity to positive infinity. And I'm using parentheses, remember, because infinity is not an actual number. Our range itself is a little bit different. You can do this multiple ways. If you want to think about it graphically and using some transformations from last year, you can do that. Or you could think about this. Think about x squared first. I'm going to change colors here. X squared has to be a positive number, right? Because anything squared has to be positive, or technically it could be 0. Right? Because anything squared is positive. A negative number squared is positive. A positive number squared is positive. And then we negate it. So that means that overall, negative x squared has to be a negative number, because x squared has to be positive, and then we negate it. So that means negative x squared has to be negative or 0, and then we add 25. okay? So any negative number we can get, right? Because if you take 10 squared and then negate that, you have negative 100 plus 25. So we can have any negative number there. So if you add any negative number to 25, that means we really have no bound. And if you think about the shape of the parabola pointing down, that's going to go to negative infinity. We're going to get as low as possible into the negatives as we can. And then the highest that negative x squared could be is 0. Because of the fact if we plug in an x value of 0, right? That's the only case where negative x squared can't be a negative number is when we have 0. So if negative x squared is 0 and you add 25, that means our maximum is going to be 25. And we're going to put a bracket since we're going to actually include it. And there's our range. We'll also try 5 here. So I'm going to do the same thing. First, I'm going to subtract x squared from both sides. And we have y squared is equal to negative x squared plus 25. And then I'm going to take the square root. So we have y is equal to plus or minus the square root of negative x squared plus 25. Okay? So the plus or minus is kind of a key here, all right, into whether or not our first question is whether or not we have a function or not, or a relation. The plus or minus is actually clues us to the fact that we're going to actually have two answers here in general, because of the fact that whatever x value we plug in, we're going to put that in, and then we are going to evaluate, and your answer is going to be plus or minus whatever the square root of that x value plugged in is, right? So you have the positive and the negative, which gives you two answers. For every x value you plug in, you have a positive and a negative. So that automatically makes this a relation. You can try it out yourself if you plug in an x value. All right, good. So that's the first piece. The second piece is, and I'm going to do a little bit of scratch work in a different color. The second piece is this. What x values can we plug in? If you remember, we're going to be dealing in the real number set. So that means that we want 0 or a positive value underneath the radical. So we want negative x squared plus 25 to be greater than or equal to 0. Okay? If I add x squared to both sides here, that means we want 25 to be greater than or equal to x squared. Okay, and then we're going to take the square root of both sides, and then we're going to have to play around with this a little bit, right? It is not just going to be 5 is greater than or equal to x. Or you could rewrite that if you want. I know some people are more comfortable as x is less than or equal to 5. Okay, there's also going to be another piece because we're taking the square root of this. We are also going to add a second piece into this, as x can also be greater than or equal to negative 5. Because we're dealing with the squared piece. And that negative piece just becomes with the fact that you're going to first take the negative of x squared, right? So x squared, anything squared is positive, then you're going to negate that. All right. So we have this piece here, as this is actually, we're writing this in, usually we're writing our domain in interval notation. We could use this piece here and write it in set builder notation if we want. But that actually is a little bit of algebra to figure out what our domain is. So we can write our domain in our interval notation first and write it as from negative 5 to 5. And essentially what we just found was we found all those values that are going to keep that negative x squared piece that's underneath the radical less than 25. So you never get a negative number underneath the radical. Okay. And your range is a little bit different here. I want you to think about what happens if you plug in negative 5, if you plug in 5, if you plug in 0, what's in the middle. I want you to think about what would happen in your relation below, where it says y is equal to plus or minus the square root of negative x squared plus 25, right? If we plug in negative 5 or 5, we're going to get 0. If you plug in 0, think about what's negative 0 squared plus 25. Well, that would just give us 25. So you take the square root of that is 5. And your answer would be y is equal to plus or minus 5, right? So positive or negative 5, right? So our relation in this case is actually the same as our domain. And I just got that by plugging in values within my domain. You can do it mentally. You can actually write it out if you would like.